So good afternoon, everyone. This is the second Sir John Mandeville Research Forum of the season, of the term. And last week was a real success with Adam Swain and his collaborators. And we managed to do it thanks to Larry and all the technical teams, both in person, on Zoom, and also on YouTube. So that's quite an achievement. So today seems quite straightforward because we're actually on Zoom and also on YouTube. And welcome to everyone who's listening from the YouTube line, as well as those of you who are in front of me on the screen. So I'm delighted to welcome Professor David de Roure, who is the Professor of E-Research at the University of Oxford and Turing Fellow at the Alan Turing Institute. And he's an Honorary Research Professor at the RNCM and the Technical Director of PRISM. So that's quite a lot, which is fantastic. And we really appreciate all that Dave de Roure is doing for the RNCM, for the development of PRISM. He's been a huge influence in the success of that research centre, working very closely with Emily Howard and the rest of the team. Dave de Roure brings very particular expertise, interdisciplinary expertise, and he works across a number of areas, including humanities, digital musicology, social sciences, social machines and web science, engineering, Internet of Things, computer science, distributed systems and sustainable software, and libraries and archives, knowledge infrastructures. If we all had that same range of expertise, it would be a wonderful position, but it's fabulous that we have that in Dave de Roure. There's also, if you look on the website, he's a blog about his role as technical director of PRISM at the RNCM, so do feel free to look at that. Today he's going to talk to us about co-creating with code. His colleague who's published very widely, who's captured an awful lot of grant applications, successful grant applications, and who is very senior in his field in all sorts of ways. So please welcome Dave de Roure to give our second seminar.
Thank you so much, Barbara. Thanks, everyone. It's a pleasure to be here. Thank you for having me. I see some colleagues on the screen, and there may be others on YouTube, and some people I've just met in the BG session, which was fantastic. Thank you for having me then as well. So I'm going to share my screen. Let's do that. Has that worked okay? Good, I'm seeing thumbs up. Yeah, so my affiliations are along the bottom of the screen there. So as well as PRISM, I'm fellow at the Alan Turing Institute, which is the UK National Institute for Data Science and AI, normally based in the British Library, in fact, just reopening there now. But in Oxford, I have a strange sort of dual existence. I'm based in engineering science, where I might do things like electronics, and teaching that, but I'm actually seconded to the humanities division of the university, where I'm responsible for digital humanities across the institution. And I define digital humanities very broadly. I don't think it's a separate discipline. I think it's the use of digital and computational methods in our humanities research, and everything I'm going to speak about today is an example of that. Here's the abstract for the talk. Just sort of do the big picture here, and then I'll explain the structure of my talk. There's a huge fashion for AI and music, and it's as if this has only just happened and only just been possible, but that's not the case. We've been doing AI with music for decades, and that's one of the points I want to make here. But AI researchers have suddenly got very excited about showing that their AI can do as well as a human, but I think we've been discussing this for some time. And the argument I'm going to make today is that this isn't so much about computers replacing humans as computers and humans collaborating, co-creating. And everything I talk about today really is coming from the work that we've been doing in PRISM, and it doesn't cover everything. You have other PRISM speakers coming up in this series who will cover other things in much more detail. So this is a bit of a whistle-stop tour, and it's a whistle-stop tour in sort of chronological order, such that by the time we come to the end, we'll be looking into the future. So I'll start by pointing out that not just AI, but computers and music have a very long history. I'm going to sort of jump in the TARDIS and go back nearly 2 centuries to start the story. Then point out that music and AI also have a long history together. But that somehow we've got into this humans versus machines thing, which I'll talk about a bit. We've just been discussing in the PGR session. And I'll talk about not making humans versus machines, but more of a harmonious existence, and some of the experiments in co-creation that have been going on in Prism, and some glimpses of what's happening currently. And at the end, we will turn our gaze to the future. And I won't explain exactly what it's going to be like in the future, but I might suggest how we might get there. So let's start with that rewind. And I'm going back to these characters, Ada Lovelace. And the period of time we're focusing on here is 1843, which is when there's the publication of the translation of Babbage's, taught by Babbage in Italy, where she added extensive notes to that. And it's things she said in those notes that have become a significant evidence of her contribution. So today, Ada Lovelace is held up as importantly, as an icon for women in computing. She's sometimes held up as the first women programmer, or the first programmer, or the first computer scientist, all sorts of things. Now, some of those things could be contested because actually she was working closely with her collaborator, her friend and her collaborator, Charles Babbage, who designed the analytical engine. And this is an artist's impression by Sidney Padua of the analytical engine. You can see the vast mechanical construction with some punch cards there modeled on the Jacquard loom. You can see Babbage and Lovelace. It's steam powered. In fact, various parts of this picture correspond to various bits of the computer as we know it today, interestingly. So Babbage's design anticipated what happens over 100 years later. Now, what Babbage was mainly interested in terms of using the computer was crunching numbers, producing tables and doing calculations. But I think the distinctive contribution that Ada Lovelace made is we could discuss whether or not she wrote the first program. There are programs in those notes we talked about. But actually, as well as being a mathematician, she was a musician, and she talked about what happens when computers could perhaps do something with music. And it's that interdisciplinarity which is uncontested. Other people weren't thinking about computers and music at that point in time, or computers and maths and music. They were thinking about other applications. So I've had a slight effort to reappropriate Ada Lovelace, the musician, in this article in 2019 in the BBC Music Magazine, where I point out that actually she really was a musician as well, and there's plenty of evidence of that. But this is often missing in the story. She's held up as a STEM icon, but she should be a STEAM icon, which may be an appropriate metaphor. This is a sort of photo of the book. This is the translation that she did of Babbage's talk in Italy and transcribed by Men of Roure. And I'm just going to put out a couple of quotes from this, which have become really distinctive and have been discussed at length for many years in probably slightly different academic communities. This is the first one. This is the music one. Supposing, for instance, that the fundamental relations of pitch sounds in the science of harmony and musical composition were susceptible of such expression and adaptations, the engine might compose elaborate and scientific pieces of music with any degree of complexity or extent. And that's something which we've been thinking about for some years now. What do we mean by a scientific piece of music? What did Ada Lovelace intend by that? And I don't think I have an answer to that, but we've done a number of creative responses to this statement. There are other things she wrote to do with whether computers can be creative. And I've chosen one quote here, and it's rather out of context, and there are others, and it's important to note that. But this is one that has led to discussion, including by Turing himself, and where she says, the analytics engine has no pretensions to originate anything. It can do whatever we know how to order it to perform. It can follow analysis. It has no power of anticipating any analytical relations or truths. Its province is to assist us in making available what we're already acquainted with, which sounds like an argument that the machine can't be creative. And as I say, there are other things that she wrote that we should consider as well. Another nice quote there, we may say most aptly that the analytical engine weaves algebraical patterns just as the Jacquard loom weaves flowers and leaves. And I offer this as an example of the way she was thinking, the interdisciplinary way she was thinking at that point in time. Right, that sets the scene. I needed to introduce those two characters because they come up in this story more than once. In fact, Ada Lovelace won't leave us alone. So, and I'm sure she'll return again in the future. By jumping 143 years, I have skipped over quite an important period, during which, for example, the electronic computer was invented. It's interesting to me that it took 143 years. When Babbage designed that mechanical device, which is still hasn't been actually created, perhaps it will be at some point, his colleague, collaborator, Charles Wheatstone, was doing things with telegraph, doing things with the Victorian internet, as it's sometimes called. We had the ability to do things with electricity, to operate relays, to send what we would think of today as Morse code, for example. And so they had a lot of the ingredients of the electronic computer back then. It took everyone a long time, and there's been a lot of discussion about why it took so long and could they have invented it then. We'll leave that for another day, but it's an interesting thought. 143 years, right? And I've landed my TARDIS in the machine room, a computer room here in IRCAM in Paris in the late 1980s, which is what I've chosen to land. It's a nice photo in sepia of what computers look like at that point. Now, why have I chosen this particular location? Well, I was a PhD student at the University of Southampton, and I was working in a programming language called Lisp. Lisp is one of the early programming languages coming out in the sort of late 50s. There was one called Fortran, which was used in scientific computing, is still used in scientific computing. And then Lisp was the AI language. So I started working in this language, and it's not really one language, it's a family of languages. And there came a point in the 80s where there was an effort to standardize Lisp. So there would be one ISO standard Lisp. And we had a meeting at IRCAM, an institute which does computer music, as we all know, actually a heavy user of Lisp to do that. And that was one of many standardization meetings. The language that, or the version of Lisp that I've most heavily used is one called Scheme. This is the book you have in front of you on the screen is this book I have in my hand. And it's the book that I taught Lisp from for over 10 years. And this comes from MIT, from Hal Abelson and Jerry Sussman. This has huge status, especially in the US, where many cohorts of electrical engineers from MIT were taught this as their first programming course. And this was also the beginning of a collaboration for me, because I visited MIT in '88 and every year until I was on sabbatical there in '97. So there's a strong Lisp Scheme MIT component to this. But one of the reasons I needed to take my physical book off the bookshelf was I wanted to look up a quote in the preface to the book, which I only realized recently was highly relevant to my talks. It occurred to me when I was on a panel in Darmstadt. I suddenly remember this. So one of the things they say in the preface is, programs must be written for people to read and only incidentally for machines to execute. Now that's a really interesting stance, because we may think programs are things we write to run on a computer. That's how we instruct the computer to do stuff. But they're really making the point here that actually humans read these as well. It's a way of expressing how to do things. It's a way of discussing that, reasoning about that, sharing it, teaching it. So the program is there for humans too. And the relevance to this talk is, I would say the same thing about musical notation. So we might be able to draw a comparison here. Okay, we produce a musical score to be performed, but you do lots of other things with that score as well. So I just wanted to set up that code music comparison at the beginning of the talk. Now to AI, having been with music for a very long time. I've already mentioned IRCAM in the 80s. So it's a great privilege working with our NCM colleagues to now be working in collaboration with George Lewis, because for many reasons, but significantly, George Lewis wrote what you see on the screen here these words back in the late 80s. And you can see some dates on a performance on the right, in October '89. But look at what he was saying then and compare that to what you're hearing today about AI and music. As you can see, we were already having these discussions back then. And I'm really pleased to give George the sort of opening words in in this discussion in today's talk, and actually I will give him some closing words as well to bookend this. So Voyager, a very significant piece. In Voyager, improvisers engage in dialogue with a computer-driven, interactive, virtual improvising orchestra. The computer program analyzes aspects of a human improviser's performance in real time, using that analysis to guide an automatic composition, or if you will, improvisation program that generates both complex responses to the musician's playing and independent behavior that arises from its own internal processes. This is fantastic. And this is a description that could be applied to much of the work that's going on today. But George Lewis was doing this in the 80s. Sets the scene really well. I just want to drop back into our friends Lovelace and Babbage. This is actually a Google Ngram view of the number of occurrences that the words Charles Babbage and the words Ada Lovelace in the Google book collection. Humanists can have a long discussion with me later about whether this was a good visualization, given that Ada Lovelace was known by other names, but I'll skip over that for the second. So you can see a sort of an ascendance of Ada Lovelace of late, and partly that's the women in computing piece, which, as I say, is very important, but perhaps not complete. But also this discussion about computers and creativity. And Margaret Bowden at the University of Sussex created in one of her books this notion of the Lovelace question, and she teased apart what Lovelace has said about creativity into a set of questions, which you see here. The first question is whether computational concepts can help us understand how human creativity is possible. The second is whether computers at some point could ever do things which appear to be creative. That's an important definition. So that's, you can define creativity in a computer to be some, when the computer does something that would require creativity in a human. That's a definition I might come back to. The third is whether a computer could ever appear to recognize creativity. And the fourth is whether computers themselves could ever really be creative. I'm not going to answer these questions today, but I think it's important to tease those apart. Part of the narrative of this talk draws on this idea of computers doing things that make them indistinguishable from humans. So now I'm going to zoom again on my fast forward button to come much closer up to date. Like before, we jumped over the invention of the electronic computer. Now we've jumped over some rather significant moments. The most significant, of course, is probably the invention of the web. A less significant one was that Lisp process did actually happen. They did standardize it, but not many people noticed. It took many years, and people aren't really using the language so heavily today. But they still do. And actually in prison, we have 2 Lisp programmers, so that's excellent. As we zoom forward in time travel, just flashing past in this sequence, I wanted to mention a couple of things that I did in this period, because I think that says something about where I come from in this and helps you understand my lens. Before the web, prehistory, imagine, before the web, there was a community that was doing hypertext and hypermedia. And it was an excellent community. This is the community that saw Tim Berners-Lee demonstrate the first version of the web, and they said, that'll never catch on. Okay, so the rest is history. But we were doing some really interesting things in terms of hypertext and navigating archives and collections. And I was working on navigating musical collections. So before the web, we didn't stick the links inside the documents. The links were stored separately, and the idea was you could take a corpus of music, for example, be that in symbolic notation, MIDI notation, digital audio, and automatically things will be linked up because you had the links stored separately, and they matched, like search operations, they matched things within the content. I still think this is a really good idea. That was 1998, we published that. That took me into the music information retrieval community, who were very, very good at extracting features computationally from music, supporting the process of musicology, for example. Something else I did then, and this, I'd love to give a whole talk about this another time. We analyzed the structure of 1,000 pieces of music using computational methods. This is working with McGill and with Illinois. And this is a project called SALAMI, Structural Analysis of Large Amounts of Music Information, arguably the best or the worst project acronym ever. That debate is still continuing. And we've released databases that are still used. by the music information retrieval community for this difficult process of structural analysis of music. We crowdsourced or grad-sourced analysis to music students in 2 countries, and then we trained the computers to do the same kind of analysis. But just the analysis that was done by the humans is incredibly useful in its own right as a quotes ground truth in analysis work. So that's my background. It's melodic pitch contours, otherwise known as query by humming, was a particular feature I was working with, and structural analysis. 2015, we've landed now in the Maths Institute in Oxford, and you can see on stage here me with pre-lockdown haircut, Emily, and our colleague Pip Wilcox, who will come again later in the talk as well. She's head of research at the National Archives now. This is the 100th anniversary of the birth of Ada Lovelace. Here she is again. This was an event organised by our colleague Ursula Martin, who's the author of, one of the authors of Ada Lovelace, The Making of a Computer Scientist. And Ursula did this because actually no one else was going to do this. Ada Lovelace doesn't belong to any particular institution who was going to celebrate her life, and that's exactly what we did. 2-day event. I had the privilege of being on the organising committee, and I was responsible for music. Fantastic. And this is how I met Emily. So Emily had already produced her Lovelace trilogy, and we did a performance of Ada's sketches just ahead of this event in the Maths Institute. And this is us on stage discovering that. And that format that Emily was using at the time had been at a sort of a late at the Science Museum, and was called Numbers into Notes. And this Numbers into Notes theme became very significant. I use a software emulator of the analytical engine to generate some music, going back to that original Lovelace quote. And that went quite well. So I took that same algorithm in the 19th century mathematics that we used and made a website called Numbers into Notes, which you can play with. It's essentially you choose your algorithms. It generates some music on a piano roll notation. You choose which bits you like, and can generate various export formats from that. We have a research version of this which generates all sorts of things. For us, it's become a test piece of test equipment. It's a signal generator to test our various other digital musicology software, as well as being used creatively. So that became a thing. The whole Numbers into Notes thing, thanks to Emily, became a thing. And I'll come back to that in a second as I talk about performances. But first of all, I want to mention this event at the Vortex in Dalston in London, which is that computational musicology community which relates to the Lovelace questions. So this is the research community that absolutely wants to produce music by computer, by artificial intelligence, if you like, which is indistinguishable from that produced by human, or to use my careful phrase, use music that would require creativity in a human. This was really, really interesting, and I'd love to talk about it for a long time because there are so many lessons in this. So it was billed as the first concert consisting almost entirely of music composed by artificial intelligence. The audience had questionnaires, and we had to tick boxes to say whether a piece of music we thought had a human composer or an AI composer. And actually, you know, the box ticking was fairly inconsistent across the audience. But I feel very privileged to have sat in the front row, and I reckon I can tell what was human and what was AI just by the expressions on the faces of the performers, because the computer wasn't really making things particularly easy, or because they were familiar with the human generative piece already. But I reckon it's possible to tell. Anyway, it was a very successful event, and it does demonstrate how well that community, that computational creativity community is doing. We can anticipate that will get better and better. And you know, that's something we might want to discuss later. Bottom right here is a colleague, Mark Dinverno from Goldsmiths, who's a jazz musician, jazz pianist, who I've known for very many years. And he takes a slightly different stance on this, which is actually one I share with him. Even if you don't think machines can be creative by themselves, they can potentially be creative friends. You can imagine a situation when you're having a conversation with a machine offering prompts as a critical creative accomplice. And that's very much the spirit of the work that we've been doing in Prism rather than replacement. I don't know if you know the piece Daddy's Car. You might want to play this later. Just find that on YouTube. It's a piece by Benoit Carré. It's fantastic. It's generated by AI by a colleague, Francois Pache, who's also an amazing guitarist. And this was performed at the Vortex, about a meter from me, and it does sound great on YouTube. A lovely Beatle-esque piece of music. It's a really good song. But again, I can see the expression on Benoit's face when he's trying to do some of those chord changes. So, yeah, computers aren't quite there yet in making it playable, but that's solvable. And then from numbers into notes, we did some interesting sort of crowdsourcing again. We got composers to generate fragments of music, and then we performed them, bring them together in real time at a performance in Bethnal Green. This is 2017 now. This is a colleague, Alan Chamberlain, who's at University of Nottingham. And I won't talk about it today, but we had hardware that was running the numbers into notes software that you've seen earlier. We have various devices, and there's a lot we could say about the electronics, but that isn't my theme today. And then Prism was founded. So you see on stage here Emily and Marcus de Sotoy, my colleague for the Maths Institute in Oxford. This is before Prism received the funding that it has since then from Research England. We launched this. This is sort of one of the early events at RNCM. And at that time, Marcus was really interested in this, can you tell the difference between human and machine generated bark? So we're still in the human versus machine piece here. And he had a performance at the Barbican called an event called the Eternal Golden Braid. Could an algorithm ever write music to rival bark? So in all the scenarios I'm about to give you, there are human performers of musical scores that have been generated by Rob Laidlow, which are a mixture of human and AI-generated bark, and they are not interleaved. They're not sort of merged with each other. There's a very clear transition from one to the other several times during a piece which is a few minutes long. And the game for the audience is to spot which bits are human and which bits are AI. So that it is interleaved, but not blurred, if you see what I mean. Rob did a really good job of this. It's quite hard to tell. And we did it at RNCN. Same human performers there. And what you can see on the screen on the left is a camera pointing at the audience, determining whether they're holding up yellow or blue cards. And the audience had to hold these cards up to say human or machine. And then we could measure that visually, as you can see on the left. On the right there, you can see the same thing going on at RNCM. Bottom left is the one of these you can find online as a video, Secrets and Lies, the Hidden Power of Maths, Royal Institution Christmas Lectures in 2019. We did so much in 2019. If you do find that online, which is easy, but the hint I can give you is you have to go 57 minutes into the 60-minute video to find the bit in question. And there you'll see, again, the audience holding up yellow and blue cards. And we've analyzed this, you know, using image processing to measure the signal of how human and how machine the audience thought it was. So we really were in that human versus machine discussion. And it's really, really good for engaging people in the discussion, for engaging people in maths and in music and in algorithms, and that was our objective. I gave one of my Oxford engineering students what sounds like an impossible project last year. Simply, I gave her Rob's music, the Barkov bot piece, and said, write a program to determine which bits are human and which bits are machine. It almost sounds like an impossible project. It's like, let's train an AI on a human, let's generate some music, and then let's use another program to determine whether that was human or machine. That sounds pretty hard. Actually, since AI isn't perfect, it makes some mistakes in the music it produces. If you know what they are, you can spot them. And this is, she did this little cartoon on her final report. Hi, I'm a composer. Would you like to listen to my music? And then the response is, wow, that's not human, you're a machine. And this is what her program had done. It could determine human or machine. And then rather intriguingly, it says, so am I. And then the two machines shake hands. I'm not quite sure what was going on here in her vision of where it was all going. But I'm going to bring the humans back into this picture in a minute. And from a musical viewpoint, to give you an example of how you tell the difference, the AI doesn't remember for very long what it's done. So if, for example, with the bark, if it modulates, it doesn't modulate back. But if you can take enough of the music and you can look at the structure, the machine generated structure is quite messy compared to the human generated structure. So using the structural analysis techniques that I worked on previously and visualizing that, you could spot the difference. This can be fixed. It will, the AI will overcome this one. Right, still human versus machine. Wearing my Turing hat, I ended up on a panel, believe it or not, at the British Embassy in Berlin, where they were having a science fiction night where they had some filmmakers and they were discussing science fiction and AI. It was tremendous fun. And my chance to have a discussion with some filmmakers and say, why do you always make it humans versus computers? And is it just because it sells tickets, So I was sort of critically in that respect, but I also had to admit that at least they were thinking about sort of social future scenarios involving AI, which I'm not always sure how AI researchers are doing. It's a very interesting discussion, but again, human versus machine. And now we change from that. So in a series of pieces of music, Rob Laidlaw has created compositions which I would describe as compositions with AI about AI. So these are co-created. And the first of these I want to mention is three dystopias, which is a word created by the AI. And I just want to show you the program notes from this performance, because what happens in the duration of the piece is that the AI becomes more sophisticated in how much it's learned. But look at the middle paragraph here. This is how Rob was interacting with the AI. It's a conversation between Rob and state-of-the-art AI network fully trained on Rob's music. So Rob would write music. The AI would do a response to that in the style it had learned from Rob, and then he would do a response to that. So this is what I mean by co-creation. This is absolutely a back and forth. This isn't the computer replacing the human. This is the two working together. And sometimes it's the surprise that comes from what's generated by the AI that causes different responses in the human to what might have come about otherwise. So it's embracing the disruption is part of the power of this co-creative method. A very significant piece followed, Alter in 2019 in the Barbican and in Oxford. We could spend a long time talking about this, and really I recommend everyone listens to Rob rather than me about this. But what was significant here is we have music created with AI about AI. We also had the mezzo-soprano singing in duet with herself, where electronics was used within that, but there's some AI processing going on, so we had some extra AI there. But the libretto was also generated by AI, and this is themed again on Ada Lovelace, which is part of the series of events at the Barbican, and this evening was curated by Emily. I just want to mention the text piece because we've done quite a lot with text. So if you just take an off-the-shelf AI online solution today, things like GPT-2 people may have played with, the model of the English language that they're using has probably been ingested from the web. It's probably Reddit, it's probably Wikipedia, because that way you can have it in multiple languages. And that isn't necessarily the language that we wanted here, because we were kind of creating a ghost Ada Lovelace. So we could prompt Ada Lovelace to say something, and she would say it, and that would become part of the text. So what we did was take the correspondence between Charles Babbage and Ada Lovelace, which is on deposit in the Bodleian Library in Oxford, and we use that to build our ghost Ada Lovelace, but we need 19th century English language model. And within the Bodleian, we also have electronic enlightenment, and they kindly gave us a corpus of female correspondence from that period, and we used that to train our language model. So we created this ghost Ada Lovelace. There's a whole lot we could say about that. And then we did some time travel, because the results of that Rob then took through the 21st century AI, and that's what was used at the event. And the really interesting outcomes in terms of the text that was produced and the things that our Ada Lovelace would say. Rob also did something which I think we want to see a lot more of in the future, which is he devised a notation for describing which bits of that were done by what was human, what was machine, how do they all link together? So if we come out of this world where something is either human or it's AI, but we go co-creational, what is the provenance of the various parts of this piece of music? What is the workflow that generated it? How can you repeat this? How can someone else use this, modify, do something else with it? We need a way of writing that down. And this is the notation called hybrid chain that Rob developed. We can use this in a kind of workshopping tool kind of way, where a number of people could write down things about their compositions based on this sort of model. And that's something we should do going ahead. I'm going to step out of AI just for a second, because not everything is AI. And I want to talk about a couple of other pieces of coding, writing small programs that have been used in the compositional process and within Prism. But both of these examples are with Emily. Then I'm going to come back into the machine learning, back into the AI. So this was the Anvil, again, 2019. What a busy year. So Emily, working with the poet Michael Simmons Roberts next door, did this amazing performance in Bridgewater Hall, which had the BBC fill and the massed chorus of the BBC singers, the three Hello choirs. Extraordinary, epic event. Really interesting what went on in the composition of this, because Michael Simmons Roberts had written a poem in the form of a grid. You see the grid poem here on the left, which is from the Peters edition, that you can find this online if you want to see more of it. This amazingly devised program, Freudian slip, poem, can be read by reading the rows, reading the columns. There's a set of rules that come with the notes for it, for how to read lines from this poem, and they amazingly work. And Emily was using this to generate the libretto for this piece. But we wanted to experiment with what are the possible readings of the grid poem. We did this by writing a program that took this, what is essentially a spreadsheet, and then would, through various rules and prompts that you could give it, play out various parts of it to give pieces of text. At a previous research forum, I've demonstrated this live. I'm not going to do it live today, but it actually gives you a 3D fly-through of the poem. So you can see here some of the sort of routes through the poem. And if you play with this live, you can travel along those and see all the words flashing past. And Emily then took that, and that was part of her process of creating the libretto. And I'll let Emily talk about that another day as to how this played into it. But it's point for the narrative of this talk is that it's an example of using some code and an algorithmic approach as part of the compositional process. Here's the second example of that, also from a piece by Emily called But Then What Are These Numbers? Again, something written by Ada Lovelace. And the interesting story of this is that when our colleague Ursula Martin was going through the Lovelace correspondence in the Podlin libraries, she found some jottings and some doodles. And this one on the top left, I don't know what people might think that was. Is it some kind of animal or whatever? But to Ursula Martin, she absolutely knew what this was, because this is a standard class example used in computer science. And it's called the Bridges of Königsberg, the 7 Bridges of Königsberg. On the right, you'll see another graphic that describes this problem. The challenge is, can you devise a walk around this city that takes you over each of those bridges once and only once? And incidentally, the answer is no. But this was a very significant problem in mathematics, because they were, at the time that the problem was formulated, there wasn't a mathematical approach to this. And the mathematician Euler, in Latin, produced the solution to this. And that became the basis of a really important area of maths, which we very heavily use today. So this is why it's a great class example. You'll notice that the diagram on the left has the bridges in a different position to the diagram on the right. And the one on the left is soluble. You can find a route through that one. So they moved one of the bridges. So we think this is Charles Babbage and Ada Lovelace trying to solve the problem. And there's the ink line drawing you see there, but you can also see a pencil, faint pencil drawing. And if you follow the link at the bottom of this slide later, it will take you to the original high quality image of that. So you can have a look at that pencil line and work out which way the pencil was going by which way the ink smudges, and work out exactly what Lovelace and Babbage were doing then. So I wrote a program which you can imagine algorithmic composition techniques that use this diagram, because you could imagine assigning notes or chords or something So those bridges, and then different roots would sound in different ways. It's a fairly obvious sonification or musification. And I wrote a program using the language Prolog, which was the other early AI language, which worked out the possible routes around this. And that generated, again, some data that went into Emily's compositional process, which had many other things feeding into it as well, and led to the piece, but then what are these numbers, which again, I'm sure Emily will talk about another time. But the point is, software tool, use of a programming language, actually use of an AI programming language. And the sort of techniques that were in use there, search, breadth first search, depth first search, would have been called AI back in the 70s. When we say AI today, we're thinking about something much more specific, which is machine learning. So how to do AI properly, right? Future Music, back in June this year, we had performances, videos from the Machine Learning for Music Working Group. So in collaboration between Prism and Novars at Manchester over the road. And this fantastic set of students producing fantastic pieces of music, which you can find online. These are tremendous. Some of these used a particular piece of software from Prism called SampleRNN. And I'm not going to steal anyone's thunder by talking about SampleRNN now, because you'll be hearing about that another time. But just to shout out to Chris Meelan, who's the research software engineer in Prism, who took this algorithm, SampleRNN, implemented it in software in a way that made it very usable, runs it on the machines in the Prism lab so that we have a resource that people can use to do machine learning. And unlike some of the other techniques that I've mentioned, we can, Rob and I were learning music almost at symbolic level rather than sound level, but this is working at sound level. This is working with digital audio. This is using sound samples. It's very, very computationally intensive. And the training of the artificial intelligence, the machine learning, takes a long time. Chris is really, really good at this. And a number of pieces you see that have come out of Prism and will be coming out are using this technique behind the scenes. So what we've done here is take an algorithm which was published in an academic paper, made it absolutely usable by colleagues in the music community and in composition to do some entirely new things. I think it's a fantastic example of how we're using AI. That is not AI replacing a human. That is humans working with it. Then finally, another AI example to mention, back in text, but working with Jennifer Walsh. One of Jennifer's interests is text scores, by which we mean text descriptions of the instructions for events. And they are, it goes back to my original point about programs being written only incidentally for computers to execute, because you could take a text score and actually perform it, whether that's musical or whatever. But you can also look at the score and enjoy the score in its own right. And what Jen has done is collected over the years this amazing data set of text scores, which is now released in August this year with this booklet, which we can share with the text score data set. There's the URL down the bottom to her website with this on as a PDF. And what she did was we trained the AI using multiple AIs on the text score corpus. This is very unique. No one's got all these text scores together before. And we generated new text scores. And then the database was put together by a colleague, Ragnar, who's in Iceland. And then Jen would curate what came out of the AI and did a really, really nice job of putting footnotes in this booklet telling you exactly which AI generated what. It's really, really interesting. And I'm just going to give you just one example of a text score that came out of this. Some of these examples are illustrated by images, which were also generated by AI. So just as an example of a text score from the book, in the course of an hour, transform yourself into a unicorn and dance with her. So it's a lovely example. I thoroughly recommend looking at this. It's a very interesting read. Now we've traveled in time to here, and perhaps we could jump forward 10 years, and perhaps I could tell you what's going to be happening in 2031. Hopefully the pandemic's ended. Other things will have happened. I'm not sure what. I'm not going to tell you this because the whole point of this talk is you're going to tell me this. In fact, we're going to do this together. We're going to create whatever happens next. And just for my last couple of slides, I want to talk about that process. So you'll hear a lot about AI at the moment, by which we largely mean machine learning. It's come about because there's more data and faster computers, and we've passed a tipping point, and there's a lot more we can do. The methods aren't, broadly speaking, new, but we can now do it. There are lots of dystopian views of the future. I am advocating a more harmonious view here, as you can tell. And just to say something about those two things, and incidentally, the reason I'm not going to tell you the answer is we're going to create it together. Here's a lovely sort of tech industry quote: "The best way to predict the future is to invent it." That's what we're doing. That's what Prism's doing, and with you, and we are inventing the future. Aforementioned colleague Pip Wilcox gave a closing keynote at the Music Encoding Initiative this year, and it touched on these themes. And she had one slide which was about the sort of dystopian views of AI, and I've just borrowed it with permission, because it makes the point about the dystopias. So these are the sort of things we hear. AI will take half our jobs in the next 20 years. People will be left helpless and subjugated to the will of machines. That's our human versus machine science fiction movie world. We're all doomed. Or artificial intelligence is a distant dream. Our current machine learning methods are overblown hype, destined to fail in their promise to improve lives. We're all doomed. Or artificial intelligence has already taken over, and our historical biases are already baked in. We're all doomed. Okay, so these are some of the dystopias. But now I want to offer the best description of the alternative view and the best summary of the point of this talk. And it's from George Lewis. George wrote this year: "It has come to pass not only that improvisations by creative musical machines are often indistinguishable from those created by humans, but also that they need not be so distinguished." Okay. So I think, yeah, let's not worry about this. Let's celebrate this. And then that's the main point of the talk. But if I have a second point, it's actually also made by George. He says, "I've often said that models for interesting improvisation technologies are the Mars rover and the problem of self-driving vehicle. Driving is basically a kind of improvising." And I find myself making this argument as well. I sit with researchers who are doing amazing things with AI, but I don't think they're thinking about what's going to happen. So they anticipate a future where AI is all around us. It's in our cars, our homes, in our vehicles, in our bodies. But are they really thinking about what it means to be a creative human being in that context? I think that is exactly what we're doing. So I can make quite a strong argument here that what we're doing in Prism and what we're doing in AI research in music broadly actually really does have lessons in it for the AI research community to pay attention to. And when I'm not standing here as a sort of slightly techie guy talking to my music colleagues, I'm standing as a slightly music guy talking to my tech colleagues and trying to make exactly this point. It's a two-way street. What we're doing in AI music has lessons in it for the future of AI. What you see on this slide is a talk and a workshop from an AHRC network event a few months ago. But that's my message to the AI community. You know, we actually are the early adopters. We can tell you something about this. And what tends to happen in digital humanities in general is people think, oh, we're adopting the tech, the digital from the science, but it's a two-way street. And that's what I'm trying to do. When I'm not here talking to you, I'm talking to the AI community, say, listen to us, we have something to say. And with that, I'll close and thank all the very many people, because everything I've presented is the work of others that I've had the privilege to collaborate in. And I'm very happy to talk about any of this now or whenever. Thank you very much.
Thank you so much, Dave. It's you've given us so much to think about, and I think, as you say, there's been the fascination of the machine and the human is something that's definitely not going away. And you've given us a sort of historical perspective and placed what Prism is doing very firmly within that, and the work of some of our colleagues and our doctoral students, and that's quite exciting to see that. I'm just looking to see if Rob is here, but I don't see him.
He couldn't make it today.
Oh, what a shame! What a shame. His ears will be burning anyway. But really fascinating and interesting that you bring in George Lewis in the way that you do into this whole conversation. So I'd like to open up to questions, and I'm sure we have people around this in this virtual room who would like to start us off. So who would like to start us off? Jane.
Hi, Jane.
I need to unmute myself, and I also need to find the reference I'm looking for. Thank you very much for a lovely talk, David, and lovely to see those quotations from George, who we were lucky enough to meet when he was on his way from Glasgow to Edinburgh to London for the proms.
Yes, that's
we
right.
entertained him en route. So I wondered if you'd like to say something about the Karajan Institute attempt to complete Beethoven's 10th Symphony. I heard about this on the Today programme the other morning, I think it was, and I've just found a link to a site that tells me something about it. Do you know anything about this?
I didn't hear the Today programme that day. But I can guess things from your one-line description there, and I'd be very interested to look further into it. So have they used AI techniques to?
They have indeed.
Yeah.
I tell you what I'll do, rather than waste everybody's time, I'll just put such information as I've got in the chat, and then other people can follow it up. But it's the Karajan. What it says here is the Karajan Institute. The director is somebody called Roure. Matthias Roure is the lead developer. They've invented an algorithm. And the Bonn Beethoven Orchestra is planning to perform this symphony. It didn't sound madly convincing to me, I have to say, the little bit that they played. The algorithm is based on language recognition technology. So they feed bits of Beethoven into the software for the algorithm to recognize. And I just thought if you knew something about it, you might be able to comment on it.
It raises a really interesting and important question, which is how do you measure the success of that?
Not quite.
So some of the things that we've been doing, I always argue, are creative responses. I don't know exactly what Daniel Lovelace would have done. What we've done with our work around Lovelace has been a creative response to that, to share that conversation and to bring other voices into it. We had a discussion in the PGR session earlier, which was excellent. So if we imagine that the AI does fix those sort of bugs that I was talking about, that we can spot the imperfect bark, but when what's called the long range dependency problem is solved, so that the AI has more memory about what it's done, and can generate the structure, and that will happen. Then perhaps we can produce a piece of music that's indistinguishable from what a human would produce. How do we measure that? Does that mean we don't need humans, or does it just mean that humans are going to do something else beyond that point?
Well, so, this takes me back to learning about the well, it is actually, it's the Turing test, isn't it? You know, is it are you interacting with a human or are you interacting with a machine? And the fact, and I now can't remember, was it Lisa who was the therapy program?
Eliza.
Actually, yes. Eliza. It was Eliza who was who was the famous therapy program. Actually, it was remarkably successful, and in fact, I think is being used,
which is fascinating.
It absolutely is.
So Eliza came from those early days of Lisp and AI, and in a way it's by Joe Weizenbaum. It really wasn't necessarily a serious attempt to write a therapist. It was making the point that in a few lines of code, and it really is one screen full of code, you can go a long way in producing something that looks remarkably good as a human sort of Turing test sort of human substitute. The way of foiling Eliza is to type garbage in.
Yes.
And you get bits of garbage back out, so it's a machine. But it's a really interesting example of how much can be done with very little.
Yes.
And conversely, you need very much to do something very much better.
So thank you very much for that. I'll get off and let somebody else.
That's right. That's fascinating. Thanks, Jane. I will follow up on the Beethoven.
I think Jane has put a link in the chat, so do have a look at that. So who would like to ask the next question? Go on. be interesting to hear from some other members. Okay, Nina, thank you.
Hi, sorry. I'm quite new to this AI stuff, and I've been looking at it from a kind of artist perspective. I just wondered if you knew, David, and thanks for the talk as well, it's really fantastic, of many examples where artists have used video and sound, perhaps in conjunction, or
yeah, that's really interesting. And there are others here who could say more about this, but this is something about Future Music 3 that I was really impressed by, and some of the people involved are here, because due to lockdown, some of the students participating in that had got into this business to be composers rather than producers of videos, and yet they needed to become producers of videos, and they were fantastic. And it says something about our amazing students, but also something about the tooling. So it is possible to find online tools to help do this. In a way, I didn't talk so much about this today, but a lot of what we're doing is about making some of these things available for others to use very easily and to use in their work. And in a way, what's going on with the image processing with AI and the video processing does give us, you know, some really useful information as to what music should look like as well. I think people have been earlier on the image processing than on the music processing. So that set of tools that people used had fantastic results, and I think we should be looking for music AI tools that work in that kind of way. I'm sure there are people here who could tell you how they did it, but I was very impressed with those productions.
Wonderful. So who would like to ask the next question? Sam, brilliant, thank you. Can't hear you at the moment, Sam. Still can't hear you, Sam. I think you're on silent.
How about now?
Yes. Perfect.
Great, wonderful. Yeah, sorry, I was just saying one thing that came out of the Machine Learning for Music working group that I thought was really interesting. One of the participants from the RNCM, who's not here today, but Ellen Sargent, had a really interesting view on the use of AI, because her research is so focused upon collaboration. She felt like she needed to honor the machine learning output as a kind of collaborator, which I thought was really, really, well, just a beautiful idea, and a really interesting one that had never occurred to me in my use of these techniques. So I wanted to ask Dave, in this future of kind of harmonious relationship between the artist and the AI, do we then have to take the AI's voice into consideration when we're assessing what we do with the materials that it generates?
It's a great question. It's a great ethical question, as Jane has just picked up in the chat. And obviously there's a huge discussion going on about AI and ethics at the moment. We have a new institute for this in Oxford, for example. Everyone's talking about it, and we have things like the Lovelace Institute, which is ironically the Lovelace Institute, which is focusing on this as well. But I just want to sort of just go back in time just a few years to when that was an earlier discussion. And I feel quite strongly about this. There was a joint AHRC, I think EPSRC project, which led to a set of principles called the robo-ethical principles. And the idea was that when people are doing robotics research, they should follow these ethical principles. And they read a little bit like Isaac Asimov's laws of robotics, about what, you know, whether robots can harm humans and so on. And I was really interested that this had occurred and that these principles were being discussed in the robotics community when we didn't have a similar set of principles being applied in other areas I was working in. For example, the web. You can do a lot of harm with a website, but we didn't have a set of ethical principles for that. So I've tried to get that discussion going back actually about 2015, but really struggled with that. People wanted to talk about it for robots and not for websites. But one of the things that emerged from the discussions at that time was the idea that, you know, machines have rights as well. and it's a really interesting model to think about, and certainly informs that debate. And I haven't followed what the current position is on whether our algorithms have rights or not, but just to put that perspective on the table as well, because it plays into what you said. And what Ellen wanted to do there was give credit, and I think that's really important in all our work. It's acknowledging the sources and giving credit. It takes us into a actually quite a complex area of where does the credit lie with an algorithm. So if someone produces a piece of software that then someone else uses to do something creative, the person who produced the software doesn't normally own what comes out. Otherwise, Microsoft would own all our documents. Okay. However, they often feel, in the work we're doing here, the people who've created the software do sometimes feel as if their intellectual property in there is affecting the output that's coming out, and they have some ownership of it. So that's one area for discussion. Another is
perhaps I could just add.
Oh, please, Chris. Yes.
Since I actually wrote the software.
Yes. Go for it.
I have very bad light in my flat this afternoon, so I won't share my screen or share my video. I don't know. I mean, yeah, I don't think that the machines have rights. It seems I just don't feel that's something I'd say. Yeah, I've not really thought about it in too much depth. You know, I ran the code, I wrote the code. Obviously, there's a lot of extra code in the background that is not written by me, so I'm using libraries and what have you. Yeah, unless they're conscious. I mean, that's the thing. It's producing a result that's musically interesting, I hope, but it's not doing that through any conscious effort. It's not like it's composing as a person would. It's producing something musically interesting, but it's not composing it.
Chris, do you think when someone produces a piece of music using SampleRNN software, they should at least give credit to the software, to you, to the training data? I mean, these are the sort of things, the sort of practices we need to establish.
That's a good point, actually. I think the training data, you know, you wouldn't have anything without that. And if it's a set of, especially if it's music that you hadn't written, yourself, certainly. I think there's an ethical responsibility there. But for the actual software itself, no, I don't think we're at that point yet. Maybe in 100 years, or maybe sooner, but I don't think. But I think it would be doing a different thing.
I think it's important in Prism that we establish some of these practices, and the alter text. You know, we and you've seen we do it. We credit the correspondence in the Bodleian, the training data. So I said I was given the Bodleian and so on. I have actually been through all that with copyright experts, and I know we're okay. But in general, it's very unclear sometimes what the copyright situations are. The training data we use from the Electronic Enlightenment Project, that would normally be available behind a paywall. They kindly gave it to us in a very raw form, and gave us permission to use it. But yeah, lots of questions like that about the training data and the outputs.
Yeah, I mean, is it
I can imagine a future where I'm composing and whatever the 10 years from now version of the Microsoft paperclip pops up in the corner of the screen and says, "I'm sorry, Sam, but I don't like what you're doing with that material. You're obscuring my contribution." You know, shakes his little fist at me or something. Yeah, so it is interesting because now, as you were saying, we're not at that point, but I think at some point we will be at that point. Maybe not in our lifetimes, but you know, all things being well, I think we will get there. So it is an interesting thought experiment for sure.
Chris, do you want to come back in on this fascinating conversation?
I think, yeah, as Sam said, when we are at that point, when machines can compose, but I don't even know what that means, because as a composer myself, and maybe other composers in the discussion might have thoughts on this, I don't think composition can be modeled by a machine. I think fundamentally it's doing something different. Yeah, but I don't know what that is. I don't know what label I'd give, the output from these things. Is it an instrument? Is it a compositional tool? I mean, it's a compositional tool in the sense that algorithmic compositional tools are useful. I mean, when you use something to produce just a random sequence of notes, I mean, that's generated by the machine, but is the machine composing in that sense? I've used tools like that for a while, for over a decade, but I don't feel like crediting the machine at that point. The finished piece is my piece, so I don't know. Yeah, so if it's composing, if the machine or the software somehow has some kind of intentionality, some kind of awareness of what it's doing, then possibly. But I mean, that's a general AI question anyway, I think.
Yes, it's the Chinese room, isn't it? If the outputs appear,
well, we'll get into that, but
yeah, exactly, yeah. But if the outputs appear to be music, then does the machine know how to compose or not? I don't know.
Well, it could get to that point, but it could still not be conscious. That might be something we discover. A machine can produce music, but is it sentient? Does it need to be? Do you need to be sentient to write a symphony?
It's funny how I've spent most of my AI-related career avoiding that question, and now I find I have to face it.
The previous project I worked on, the John Cage project, in Huddersfield, it's a cageconcert.org, if anybody's interested. So it's a piece turning John Cage's 1957 piece, a concert for piano and orchestra, into an app, essentially. And the piece itself, in case you don't know it, it's kind of algorithmic. There's a lot of randomness in there, so it's generating output randomly. But and there are kind of little constraints on the randomness, kind of little rules. But it turns out you don't actually need very many rules to produce something really interesting, and something that actually sounds like it could have been composed by a person, even though there's no AI there at all, really. It's just a kind of randomness with a bit of constraint on top of it. So I don't know.
I think there are other generative music tools which we've been using for some time, which raise some of these questions, and I'll answer specifically AI. Sam, what's the microtonal one? There's a fantastic website where you can look at or devise microtonal scales, and you can also generate music on those scales with a lot of control. So the human using it performs and composes the piece of music. So it's a really nice example of an online tool. Yeah. What is it, Sam?
It's by an artist called Khayyam Alami.
Yeah.
And I'll put a link to it in the chat.
Yeah, it's fantastic. I've been using it over the summer to generate some quotes Egyptian music. That's a whole other discussion. But it's another example of software being written by someone. It's very good, put in the hands of musicians, and they're producing pieces of music. Maybe crediting that software. I have.
I wonder if we can hear from Bofan or Simon or Nate or some of the doctoral students who are composing using Chris's software and using AI ideas and practices. Do we want to say anything? Simon.
I don't have anything specific to say. I haven't really used the AI as such.
Okay. So. All right. Well, thanks for coming back. Bofan, you have, haven't you?
Hi, thanks everyone. Thanks, Dave. That was really fascinating. Unfortunately, I wasn't involved in the earlier this year and also this year, but that's definitely something I would love to do. I do have a question in this regard to both Dave and which is about how do you see for anyone who's wanting to creatively engage with algorithms and machine learning in their creative practice, how machine learns and writes.
I think that broke up a little bit. I didn't quite catch all of the question.
Yeah, sorry, my internet's really bad here. My question is about so how important it is for us to understand how the algorithm work.
Oh, that's a great question.
I'd say, well, it depends. I like to know, you know, I'm a composer myself, and I like to know how the, and I've been writing code as part of my compositional work for probably over 10 years now, actually, since the mid part of the first decade of the century, and initially kind of stuff. And I like to know, you know, what's going on behind the scenes, but that's just me. I mean, you don't have to. No, I mean, don't think it's necessary. It's interesting. I mean, if you write code yourself, it does change the way you write, I think. Although it depends on the programming language, however, probably, I think. So yeah, I specifically with regard to our stuff, I'd say no. It helps to learn, you know, to be kind of slightly technically minded. You don't necessarily even need to do that.
I mean, my first answer is if you do want to know how it works, Chris has written an excellent article, which you can find on the Prism website. This discussion about how much you need to know about programming and algorithms is a discussion that comes up often in digital humanities, and every year we have the digital humanities at Oxford Summer School, and that discussion will occur at some point. And there are a couple of schools of thought. So one says you might not need to know how to code, you might not need to understand the algorithms, but you need to know enough about it to have conversations with those who do. So and that's a good working model. And there's another school of thought that says actually it's quite easy to learn how to code, so people should just do it. And there's some people who feel that very strongly as well. And what you've identified, both, is an intermediate one, which is not knowing how to code, but knowing what this code is doing. And I think I would argue in favor of that for all sorts of reasons. And certainly, I mean, stepping outside music and sort of practice research here, more broadly into humanities research, although they don't use the science term reproducibility or repeatability or replicability so much, I think it is really important when humanists are using methods involving computers that there is some record of how people have done things, if only so that that can be shared with others, and also so that it, you know, keeping track of what you've done is a way of communicating with your future self when you've forgotten what you did and you want to do it again. Yeah. So I'm really quite I definitely encourage people to understand what it is they've actually done and make a record of that. What do you think, Chris?
Yeah, I think to follow on, to kind of continue on from that thought, it's kind of maybe modify what I said earlier. Yeah, I think certainly in terms of machine learning, it does help to, and that article that I wrote, thanks for the plug for that, Dave. Yeah, Hope is a decent article that introduces machine learning in a very general sense, but also how it applies to composing, how you might use it as a composer. But it does probably, it does help to, I mean, there aren't actually algorithms so much that you need to know, but it's more kind of how the technology and how neural networks work, say. A decent understanding, a kind of working understanding of what that is and how they work might be useful, probably would be useful, yeah. But in terms of, but that might lead you into coding. I mean, this often happens. you know, once you get the bulk. Yeah.
I think if I could just add a little point of slight difference, I would say that if you want to understand the possibility space of whatever area you're working in, well, you have to navigate to the edges of where you understand now and see what else there is around. Like, it's hard to imagine in a language when you don't know the vocabulary or you don't understand the core concepts. And I think to get the best overview of the territory, that whatever territory you might want to engage in, whether it's machine learning or algorithmic composition or something else that isn't kind of computational, I think having an overview of that territory is really valuable and useful, even if you're not going to make everything yourself and be really engaged at a very low level. It's useful to know the core concepts and the key ideas, because they will inform how you connect different approaches and different theories together, and how you will construct your own ideas, really. And I think I couldn't at all do what Chris has done, but knowing a little bit has helped me to use the tools that he created in my own way. And I think that I would encourage no one to be a passive recipient of technology. I think we kind of owe it to ourselves to know just a little bit, you know enough that we can make our own moves a little bit. So I wanted to add that at the end.
That's a great passive recipient of technology. That's a great soundbite. Thank you, Sam.
I think that might be a good point to bring this to a close, and to thank David de Roure for a fascinating, really broad-ranging and very thoughtful presentation today. And you've got us looking into the future a little bit, as well as understanding the past and understanding what PRISM is doing within the context of all of that, and the collaboration that is happening there, and your position in relation to that. So that's very exciting, and also very timely. It is a preoccupation of our time, and it's great that you and your colleagues are engaging in this. So if we have people who have, I think we have had some difficulties, some people joining on YouTube, I've heard that, but hopefully people can listen again, and we'll make sure that we share the YouTube version of this talk, which will be edited at the start because it started before we'd really wanted it. So we'll make sure that people have the chance to come back and watch this talk, and also to follow the discussion, because it's been a very rich and interesting discussion, and that's one of the beauties of the Research Forum series. I really appreciate all our colleagues in doing that. So thank you, David, and please, all of you, next week we have a Research Forum with Peter Asimov, who's going to talk about something completely different. He's working on France and on late 19th and 20th century French music, but also philology. So he brings a very interesting dual expertise in those two areas. So you can join us in person, you can join us on Zoom, or you can join us on YouTube. So we are getting our heads around all of this, and it's a great way that we can communicate with as many people as possible in the most convenient way. So David, thank you very much, and everyone, great to see you, and see you all next week. Thank you.
Thank you for having me.
So, bye-bye.